Okay, Jeff, you know the rights. Lisa, you're good to go.
Excellent. Well, thank you. Welcome back, everybody, to our late afternoon session. Kicking us off will be Jeffrey Demaine, who is the bibliometrics librarian at McMaster University. Jeff is the first bibliometrics and research impact librarian at McMaster University, and he previously performed the same role at the University of Waterloo, filling in for Shannon Gordon. Jeff became interested in this field while studying the history of science at Concordia University. He worked as an information scientist at the National Research Council in Ottawa, and then as research fellow in Germany. His specialty is implementing algorithms to expose the trends hidden in the data to tell the story about the evolution of research. His previous BRIC talks have demonstrated the use of main path analysis and Sleeping Beauty algorithms to analyze bibliometric data. So Jeff will be speaking today on fractionalization of research impact reveals global trends in university collaboration. Jeff, I'll hand it over to you.
Okay, thank you so much, Lisa. I've actually shortened my title because that would seem rather cumbersome and it wouldn't fit on the screen. So I'm going to shorten it to fractional counting and the dispersion of research. Now, I'm sure, I thank you all for being here. I'm sure you're all fascinated by fractional counting because you think it's a really exciting topic of study. And I have to tell you that that is not the case. Fractional counting is really boring, really boring. But I'm going to tell some interesting stories using fractional counting that are themselves quite interesting patterns. Whoops. Back. What I'm doing today is, in a sense, I'm trying to forecast the future of bibliometrics, of science, using the technique of fractional counting. Just like meteorologists, weatherman predicts that a storm is coming based on barometric pressure or temperature or something like that. I'm trying to use bibliometrics not to count last year's H-index. I really don't care about last year's H-index, but to tell us something about where science is going. And you can use citations, use collaborations, or in this case, fractional counting. And the question I'm trying to get at is, what can fractional counting tell us about the changing shape of science? So a little bit of background here that's kind of important. You might recognize the first author of this paper. He was our keynote speaker this morning. Vincent Lervière wrote this quite interesting paper 5-6 years ago, talking about team size. Team size matters. Longitudinal study showing that the size of research teams has increased over the past century. And we, in the popular culture, we see scientists always as solo researchers. When you think about the Hollywood portrayal of a scientist, it's always some old fellow with crazy white hair working alone in a lab. But that's really not the case anymore. That's a very 19th century view of how science works. And so what Vincent Lervière and his collaborators found is that team size has increased over the 20th century. Collaboration has gone up, and that generates more citations. The bigger a research team is, the more likely it is to do really good science and to attract more citations. So that's some of the background for what I'm doing today. Team size matters. And here's another report that came out just a couple of years ago, published by the ISI. This is sort of the think tank behind Clarivate. And they're looking at the situation of multi-authored papers, this sort of subset of the publication universe where you have lots and lots of co-authors. And they've noticed that, it's a small but growing percentage of the of scholarly communication, and it has strange characteristics. The CNCI of these multi-authored papers is very high, and they say that these kinds of papers are such outliers that they should really be treated separately. The quote down there in blue, articles with more than 10 authors should be acknowledged and separately described because they'll influence interpretation. All right, so that's more background for us there. Here's an even weirder one. This is not by ISI, this is by ICSR, which is the think tank behind Elsevier. And they're looking at the productivity of authors at the individual author level in the context of collaboration. And here you go. They found that as the number of co-authors per article has increased, but the amount of authorship that an average author is involved with stays the same, the actual net total output per author is shrinking, which is kind of strange. More authors are coming out, but there's more co-authors, and yet the productivity of an author tends to go down. And they hypothesize that this has to do with a certain overhead. There's a cost to collaborating. Kind of weird. So that's really what I'm getting at today, the effects of increased collaboration. Now, what we just saw on the last slide is at the article level. We've seen so far that that collaboration increases the impact of an article. That's team size matters. It also results in this strange multi-authorship kind of article that has strange characteristics. And it leads to a counterintuitive trend, which is that there's a decrease in author productivity, even as the number of articles increases, which is backwards. If you can figure that out, please let me know. So today I'm looking at collaboration at the institution level. What's collaboration doing to productivity? Not at the author or the article level, but when we think about universities. And in order to do this, you have to think about fractional counting, because otherwise you're counting the same article twice. And the questions I'm trying to get at are, how does fractional counting affect the dynamics and the structure of science? And what does fractional counting mean for the rankings of universities? So there's really two parts to my talk today, the trends in citation impact. I'm going to give an example of what fractional counting looks like and really dig into the data specifically about the University of Waterloo, because I used to work there and they're our host today. And so I'll pick on Waterloo. And then in part two, I'm going to talk about this, take a step even further back and talk about global trends in research and what fractionalization can tell us about that. Just the three takeaway key messages today, in case you fall asleep in the next 20 minutes. The trend toward increased collaboration results naturally in an increased division of credit. And this, one, reduces the university's impact over time. Two, shows a divergence of research between East and West. And three, reveals a shift to what I call a dispersed form of science. Okie dokes. Here's an example of what fractional counting looks like at the very detailed level. Again, this is an example from the University of Waterloo, and I chose this article because the last author, Linda Nazar, is a very prolific author from the Waterloo Institute of Nanotechnology. And so let's dig into the details here. There are 6 co-authors on this paper, and they're from 2 different institutions. There's 4 authors from the University of Waterloo and 2 from BASF, that company that made all those cassette tapes, you'll remember. And at the author level, you can say that each author wrote a paper. You know, Linda Nazar says, I wrote a paper. And Thomas Weiss says, I wrote a paper. So does that mean that Waterloo can say it wrote 4 papers because it has 4 authors on this article? Well, no, there's only 1 article. So does that mean that Waterloo claims 1 paper? Well, that doesn't work either, because then BASF can claim 1 paper as well, and that ends up being 2. It doesn't work. So the little table over on the right-hand side shows you how fractional counting works. Each author wrote 1/6 of the paper, which sounds ridiculous. No one talks about writing half a paper or 1/6 of a paper. But when you aggregate things at the university level, this is the calculation that goes on behind the scenes. And so you add it all up by organization, and you see that Waterloo actually gets 0.66, or 2/3 of an article, and BASF gets the other third. Now, what this means in terms of citations, if you'll see top in the bibliographic metadata there, this article has been cited 770 times. Waterloo naturally does not get to keep all 770 citations. Waterloo keeps 2/3 of that, which is in red down below, 513. Okay, so we all understand how fractional counting works at the micro level. Now let's take a step back and see what this looks like at the university level. And I'll talk about the data a little bit here. I'm using the Leiden dataset from 2020. Comes out in June every year. And this is what it looks like. There are 1,100 or so universities from 65 countries in the Leiden dataset. It covers 10 time periods of 4 years each, so a decade there. And what's of interest to us today is it counts all the publications 2 times. First, it counts them when as whole documents, that is to say, when the fractional counting column is set to 0, that's no. And then just below the red line, the exact same articles all over again, but now the fractional counting toggle switch is switched to 1. That means, yes, it is fractionally counted. And it counts the number of articles at 3 levels of citation impact: top 1%, top 10, top 50%. And it does this across 6 research fields. Now, today, I'm just going to focus on the all sciences, the summary field, because there's just, too much data to look into in a short presentation. And what I'm talking about for the rest of this little talk is basically the 2 patterns. There's actually 2 patterns that jump out at me in this table over on the right-hand side. Can you see them too? Well, very interesting patterns, and I'll highlight them for you. Above the red line, we have whole counted papers. And you'll see that at the beginning of the decade, Waterloo published 6,923 papers. By the end of the decade, it had produced 11,349, an increase of 64%. That's great. Now, let's look below the red line. We see that fractionally counted, Waterloo produced 4,131, and that increased to 5,900, which is an increase of only 44%. Now, remember, these are the exact same articles, just they're being counted as integers above the red line, 1, 2, 3, 4, 5, and below the red line, they're being counted as fractions, 0.6, 0.5, 0.33, and they all add up to 4.31. So what happened to the 20% between the 64% whole papers and the 44% fractional papers? Well, that other 20% went to the collaborators. There's 20% more collaborators at the end of the decade, and they got those fractional articles. Graphically speaking, here we're looking at citations, not articles per se, but it's the same effect. The whole counted articles are the blue line, and you'll see that that's increased quite a fair bit. But when you get down to fractionally counting the citations to those same articles, you'll see that the slope is increasing at a much slower rate. And the difference between the 2 lines there, the blue and the orange, is the number of citations that are, in a sense, lost to your collaborators. Those citations don't disappear like, socks in a dryer. They go to, well, your collaborators. And the distance between the blue and the orange line is increasing because the number of co-authors is also increasing. So what I'm doing in this research really is I'm dividing the orange line by the blue line to get a ratio of fractional to whole articles. And that tells us how much collaboration there's been at each level of citation impact. All right. So what this means is that there's what I call the fractionalization of research impact. As collaboration increases, the fractional impact of that research decreases. So in green, we'll see in 2006, 2009, there were 6,923 whole counted publications. But those same publications, if you count them as fractions, is only 4,131. You divide the fractional by the whole, and you get a ratio of 0.59, well, almost 0.6. So that means that 40% of those, that means that Waterloo was 60% of the authors on those papers, and the other 40% are the co-authors. By the end of the decade, in purple, we see that the ratio has decreased to 0.52, a decrease of about 7%, or relatively 12% from the starting point. And this is what I call a Frax tax on impact. You're collaborating, and so you have to give away, as a form of tax, some of the impact to your collaborators. Now, that's one trend. I said there were two trends. Do you see another trend in the data here? Anyone? Anyone? There's also fractionalization going on. You can measure it in terms of at different levels of citation impact. So here we have the top 1% most highly cited articles produced by the University of Waterloo. It started out being 76 whole counted articles at the beginning of the decade, and that was up to 197 by the end of the decade. But fractionally speaking, the increase was much less. And you can compare the fractionalization ratio in green versus blue and see that there's been a decrease of, for the top 1% most cited, of 12%, which is higher than the 7% we saw on the previous screen. Remember? 7% on average decrease for all publications, but 12% for the best, most highly cited research. And that means that Waterloo's best research is returning ever less impact than its more average publications. It's a second trend that I see in the data here. Graphically speaking, you can split out the fractional impact that Waterloo is retaining by level of citation percentile. So the top 1%, that's the best research, is the blue line, and it has the lowest, or the greatest amount of fractionalization, because, as we saw at the very beginning, team size matters, right? Its top 1% research gets the most citations because it has the most co-authors, which means that you've got to share out more slices of pizza, if you will. The purple line up at the top is the research in the bottom half, that is to say, it receives less than 50% of all the citations that, in that particular field. And you'll notice that the fractionalization ratio is, well, it's less, it's a less severe fractionalization. Waterloo gets to keep more than half of the credit for those articles, 0.55%, because on these papers, on average, Waterloo is at least half of the authors. Now, what you can do with these lines we just saw is run a regression line through the middle of them, right? And that allows you to characterize the pattern in the data. So the little black dots are the individual fractionalization ratios from year to year, and the blue line is the linear regression trend through the middle. And as you'll all remember from your stats class, a linear regression looks, the equation is down there in blue. Y is equal to A, which is the intercept, plus B times X. B is the slope of the blue line, plus E, which is the error. And the total error, which is to say the gray fuzziness in the background there around the blue regression line, that's the error that can be described by R squared, the coefficient of determination. And so for this particular line, which is Waterloo's top 10%, the R squared is 0.82, so that's pretty high, and the slope is 0.087, less than 1% per year, pretty slow decay. So what do I do with this regression? I've got a pattern here. Next, I want to see if there's a pattern within the patterns. All right, following me along here? So a linear regression trend is a type of pattern. That's the blue line we just saw. What I did is I did regressions for all of the universities in all of the research fields for all of the different levels of research impact. So that is to say 912 regressions for the top 10%, 912 for the sort of middle 40% there, and 912 for the bottom half, the bottom 50%. So that's a lot of regressions. That's, look down here, that works out to 16,000 or so different regressions. And now what I want to do is I want to see if there's any patterns within these 16,000 regressions, which are themselves a type of pattern. So I'm going to rank the regressions by R squared and then look at the slopes. And I want you to help me by looking for qualitative patterns in the universities. All right, I want you to tell me perhaps in the chat, what do you see in terms of qualitative patterns? All right. So here we have just the top 10, top 12 in terms of the most, the highest R squared, highest, the strongest coefficient of determination. What is the strongest, most accurate pattern? I ranked them from top to bottom, so 0.99 all the way up there. These universities tend to have a slope that is slightly negative, about negative 1.6% per year. And we can tell that these universities are very focused on increasing their collaborations from year to year because the level of R squared is so high. I don't know if the football team is going to win the championship next year, but I guarantee you that they're going to collaborate a little bit more, 1.6% more. All right, so that's the quantitative trend that I've identified. I want you to tell me if you can identify a qualitative trend in the universities. All right. So you see a pattern here? The universities that focus with laser-like precision on increasing their collaborations from year to year are also household name sorts of universities, big Western universities. MIT, Harvard, Cambridge, Oxford, McGill, Yale, even University of Ottawa's in there. Isn't that interesting? So collaboration is a very strong, is a strong force in describing what research that these universities undertake. And you can understand how this works. Harvard can collaborate with anybody it wants to because of the reputation. And so it's easy for these universities to accrue new collaborators every year. The teams get bigger and bigger. And of course, there's a monetary incentive as well. You want to collaborate with Oxford? Well, bring your grant money. You know, so that's I think that's how it works. Looking at the, I chose a sample set here of the 55 highest ranked universities. The previous screen just showed you the top 10, but here's 55 of them. And you'll notice a geographic breakdown. All of these countries, all of these universities tend to be in rich, advanced Western economies. They have an average slope of negative about 1.6% per year, which is to say that these top universities, Harvard, Cambridge, all those ones, are seeing their research impact decline by about 17% every decade. Interestingly, the one university that jumps out here is Brazil. That's the one country that doesn't look like the other ones. And that's because it contains the University of Sao Paulo, which is a very prestigious university. And so it is really part of the collaboration networks that are going on in the rest of these countries. So what does it look like the other way around? We looked at the top. Now let's look at the bottom. All right, now I'm going to choose the 55 universities that have the lowest R-squared, about which we can say very little in terms of their collaboration trends. These universities may collaborate, they may not. You can see the slope. Sometimes it goes up, sometimes it goes down. On average, it's pretty flat. All right, so there's no real trend to collaboration at this university. And now this is the quantitative pattern that I've identified on the right-hand side. Can you see if there's a qualitative pattern in the universities? Right? This is a very different list than what we just saw at the top-ranked universities. And from a geographic distribution perspective, we see that a lot of these universities are in China, India, you know, South Korea, Brazil, Turkey. Interestingly, there's 5 from the United States, which kind of jumps out as an anomaly. So I looked into those. Turns out that 2 of them are from Puerto Rico, which is technically part of the United States, so it qualifies there. And one of them is also the Michigan Technological University, not to be confused with Michigan University. This is Michigan Technological University, which has produced numerous notable alumni that have gone on to great careers in the NHL and the NFL. So it's clear that Michigan Tech University is really a school for jocks. It's where you learn how to play sports. And that would explain why collaboration is really not much of a priority. So what do we do with these trends of trends? Well, bibliometrics is not about GIFs or rankings, that sort of thing. Just like oceanography is not about measuring the height of waves, not interested in H-indexes, GIFs. By doing a statistical analysis of bibliometric data, it allows us to make predictions about the structure of science, to make predictions about future trends in scholarly communication. So we saw before, certainly with the top-ranked universities, with an R-squared coefficient of determination greater than 0.8, we can be very confident of where this trend is going. Right? So we can therefore extrapolate into the future. So what do these trends tell us about scholarly communication? The little vertical red line is where we are today. And these different slopes are the average fractionalization ratios at various levels of citation impact. You remember the top 10%, top 50, 90%, the bottom half. And as we saw before, team size matters. The top 10% most cited research is being fractionalized quicker than the top 50 or the bottom half. And as we saw with the, for example, the Harvard's, the top ranked universities, the coefficient of determination is extremely high. It's above 99%. So we can be sure that this blue line is going to keep on descending down till, well, less than 10%. And I chose 10% as the area of what I call dispersed science, where the University of Waterloo, or whichever university you want to take, only retains less than 10% of the impact for its best research. That is to say, it has 9 or more collaborators. And so what does it mean for a university in terms of its research strategy, in terms of its priorities, if all of its best papers are also done with 9 or 10 other universities? How does the university distinguish itself? This is something that, Jonathan Pendleton, the research at ICSR have also wrote about this, that, for example, small countries like Malta or Iceland, you can't really distinguish the research strengths of Malta or Iceland because they're such small countries that that they have to collaborate with so many other countries that you can't distinguish what makes research in Malta typically Maltese. And that's That's where most universities are headed. This area of dispersed science, where a university retains, less than 10% of its research impact, corresponds to this this type of multi-authorship that was described in this report by ISI, where articles have 10, 11, 12 authors and are themselves quite strange. Well, what happens when most highly cited research is this kind of outlier? If everything's an outlier, what's normal? So the implications of this fractionalization trend are that high impact research will be, I call it, dispersed within 10 or 12 years. Each university will account for only 10% or less of the content of a paper. So how can we then say that the research was done at that university? And does the university's research strengths matter anymore? It also means that the strange characteristics of multi-authored papers become the norm. And it sort of makes me scratch my head thinking that, increased collaboration is seen as an indication of research excellence, right? The more you collaborate, team size matters, more citations, that's great. But if the university ends up receiving less credit, why bother? And it also implies that rankings are based on increasingly thin slivers of credit. To use the metaphor of pizza, now that we've just had lunch, is it better to have a thin slice of a jumbo pizza, or is it better to have a bigger slice of a medium pizza? Right. Another way to think about this is speaking of fractionalization, here we are, fractionalization of seconds. The difference between the first place and third place in a 100-meter sprint comes down to milliseconds, and I think that's where rankings are going. We're going to have Harvard in first place, Cambridge in second, Oxford. It's always going to be the same order, but really we're talking about adding up tiny, tiny slivers of credit. If every article has 10 or 12 or 15 different universities attached to it, is there really much of a difference? No. Just as an aside, I'll take a moment here and talk about someone you should look for at the Tokyo Olympics. The winner of this race in 2017 will be lining up in the starting blocks in Tokyo, age 39. He's got white hair on his head, and he's going to be running in the Olympics. Watch for him. So, in summary, how does fractionalization affect scholarly communication? Well, increased collaboration leads to reduced impact, our so-called Frax tax. Strangely, less collaborative universities or less cited publications retain more impact. Increasing fractionalization across all major universities reveals a shift to a sort of a networked or dispersed form of science. But there's no such trend in the global south, which tells me that science is splitting into two different camps. There's a highly connected north, where everyone's collaborating on everything, such that you really can't tell Harvard apart from anyone else, and a separate, distinct south, which collaborates a bit, but is kind of removed from this other network. So the surprising thing also from this research is that fractional counting can be interesting. And thank you for your attention. And this is a rich vein for further research, some future questions I might explore, in subsequent work, or perhaps for next year's talk, is does the delta, the change in rankings correlate with the change in fractionalization? Are less collaborative universities actually going up the rankings because they retain more impact? Perhaps we could use betweenness centrality from social network analysis to see if that correlates with fractionalization, that sort of thing. So this data is shared on the Scholars portal Dataverse, and the link is there. And if you think this is really interesting, I don't think everyone thought that fractional counting would be interesting, but could be. If you want to work on this, then just get in touch with me. Thanks. Questions?
Fabulous, Jeff. Thanks so much. We do have a few questions. First one that came in, would you be able to elaborate on the division of credit and fractional counting? I've always personally conceived of authorship as more binary, either included or not included, rather than factoring in author order. This is certainly less rigorous or semantic, but I'm curious what all I'm losing from that methodology or approach.
Sure. Yeah. So there's also an area of research, in a sense, somewhat separate than fractionalization, in terms of trying to understand, who's first author, who's last author, because that means something in certain research fields. And certainly in the biomedical field, being the first author means it's sort of, it's your baby, it's your idea. But being the last author means that you run the lab. Whereas I think in mathematics, they're much more egalitarian, and they do it alphabetically, right? So for someone whose name begins with Z is always the last author, which could be a good thing, but that doesn't mean anything in that particular field. So the way the Leiden data set works is they're using this form of fractional counting, which they describe on their website. Is fractional counting aggregated at the level of the institution? So you divide the credit amongst all the authors and then add up how many authors are from University X and how are from University Y and all that. So it's really about fractional counting at the institutional level, so that you're not double counting, the output of University X and University Y. But it's not. It's somewhat different than trying to figure out, the prestige of being first author or last author. In this data set, it doesn't matter what order the authors are in. Does that help?
Okay. Our second question is more of a comment. This is an interesting analysis, would be to compare Waterloo-only authors versus collaborations papers and see citation and pub number changes, as well as changes on top citation numbers. Do you have a quick comment on that, Jeff?
Well, yeah, in fact, we can back up and we can see back here in the fractional back here, in a sense, the difference between the blue line and the orange line is the number of citations that are lost to your collaborators. If you don't collaborate with anybody outside Waterloo, then the two lines overlap, and Waterloo gets to keep 100% of the credit. So collaboration, team size matters. Collaboration does lead to more citations, more impactful research. But if you have to share most of the pizza, I wonder if it's really worth it, So yeah, that would be an interesting thing to see if there's actually more credit as a whole retained by the university for work that is less collaborative and retains more research. For example, there you go. Bottom half is less cited, but you get to keep more than half of it. Whereas the top 1% it's cited a lot more, but Waterloo gets to take home less of it. And as we saw, the blue line is steeper than the less collaborative, the less cited research, which looks like this. So in 10 years, the blue line is going to hit the yellow zone and become dispersed, when Waterloo or some university retains 5% of the impact. But at the same time, the purple line will be well above, will be up at 40%. Okay? So which research has more impact? The best research, or that's really confusing. Is the best research worst, or is the worst research best? Kind of a head scratcher.
Oh, and we've got time for one more question. This attendee says, I'm wondering what Jeff thinks of author with multiple affiliations. We see more and more of these in our data sets. For example, authors that are affiliated with more than one organization and sign their publications with all of their affiliations, sometimes 3 or 4 organizations. And I will say we see this at the Waterloo Institute for Nanotechnology as well.
Yeah. Well, there's 2 things. First of all, I don't know how Leiden, how CWTS, allocates authorship to this university or that university. If, Professor X is cross-appointed at 4 different universities, they've got to pick one. They can't, credit 4 universities all at the same time, because then that's just a double counting problem all over again. But what this graph that just happens to show right here is that everything's becoming so dispersed, so networked, that whether a professor is at 1 university or at 4 universities, it ends up being the same thing, right? So that's perhaps one comment.
And 2 more very quick questions came in. Sure. Are you talking about rankings in general? Because many of the rankings, THE and QS at least, depend a lot on the reputation of the university, whereas fractional counting doesn't really matter.
Yeah, exactly. So this is the Leiden data set, which is very transparent, and so you can rank universities based purely on citations. Of course, QS and THE, that's all black box kind of stuff, but they have to use fractional counting when say there's only 20% or 30% of the score of THE that adds up, that contributes to the final ranking of the university by THE. They've got to use fractional counting in there. Otherwise, again, it goes back to, they'd end up with, they're just double counting everything, So even though it's diluted a lot in the QS and the THE sorts of rankings, fractional counting does have an impact ultimately. But yeah, it'd be much more apparent in the Leiden data set.
I think that answers the last question. Is the argument therefore for universities to ignore fractional counting?
Some universities do. It's coming out in a paper. Hopefully it'll be published real soon on this topic. I think it's in Belgium. Different jurisdictions count publications either whole counted or fractionally counted, depending on the jurisdiction, for promotion purposes. So if you're a professor at the University of somewhere in Belgium, it's whole counted papers. So it doesn't matter if there are 10 or 20 co-authors on the paper, you get a score. You get counted as having produced a paper. It's 1, 2, 3, 4, 5. Whereas other universities, other jurisdictions like in Scandinavia or certainly in North America, would use fractional counting. So if you have 10